So in this video, we're going to talk about transcription, translation, and point mutations. But before we do anything, we need to determine which is the template strand and which is the coding strand. For this DNA sequence, transcription starts from the right side. However, the coding strand must be read from 5' to 3', so we're going to have to flip it. Transcribing the DNA involves replacing thymine bases with uracil. After that, we need to identify the start and stop codons. Translation begins at the start codon and stops at the stop codon. So the codons are listed here, and we use these to determine the amino acid sequence of the protein. And this is the resulting protein with 5 amino acids. In a missense mutation, the new codon codes for a different amino acid, which changes the amino acid sequence in the resulting protein. So for this mutation, it'll be a transversion by replacing one guanine base with a cytosol base. So the new mRNA sequence will include a different codon, and this codon will replace arginine with serine. In a nonsense mutation, the mutated codon codes for a stop codon, ending the translation of mRNA early. So for this mutation, it's going to be a transition mutation, replacing one adenine base with one thymine base. So this new amino acid sequence will be shortened because this new codon codes for a stop codon. In a silent point mutation, the new codon is synonymous with the original codon and codes for the same amino acid. So for this mutation, it's going to be transition from replacing a cytosine to a thymine. And as we can see, the new codon also codes for phenylalanine. In a read-through mutation, the codon, which was supposed to be the stop codon, now codes for an amino acid, which extends the amino acid sequence and makes the resulting protein longer. So this will be a transversion mutation, replacing one adenine base with a thymine base. And as we can see, the GGAUG codon doesn't code for a stop codon, which means the amino acid sequence will continue on.